Okay, good evening, guys. Thanks for being here on a Saturday evening. And before we start, I need some vote from you guys. If you're from Form 4, kalau daripada tingkatan 4, tolong pergi dekat participant tu, click on yes. Okay, click on yes if you are Form 4. I just need to know the count for the Form 4. Okay, only 3, which is Mian, Rahul, and Yish. Okay, great, Yish. No problem. Thank you so much for that. And how many of you learning physics in Malay in school? Okay, if you're learning in physics, please click yes. Kalau belajar dalam bahasa Melayu, fizik dalam bahasa Melayu, tolong klik yes ya. Nisha and Avi ya. Okay, both of you. Okay, my class today will be on dual language, on the definition and so on. Also Priya. Okay, Priya, I know. Okay, so the rest, what happens here, I might go through in English, but I will also add on Malay comes to the definition and so on. So kalau tak faham apa-apa, just ask me to repeat back, then I will repeat back again. Okay, now. You might be wondering kenapa cikgu ada kedua-dua Form 4 dengan Form 5 dalam kelas trial ni ya. Chapter light ni, it falls both for KBSM dengan KSZ. That means the new syllabus also has this chapter. Untuk syllabus baru tu, KSSM, ini ialah chapter terakhir. HP, please mute yourself. Okay, I got to mute you. Okay, if you are from Form 4, KSSM syllabus, maksudnya ini adalah chapter terakhir you. Manakala if you are from, hold on ya. Okay, manakala if you are from Form 5, I know you guys know that this is exactly your chapter 5 here. Syllabus wise, both of you learn the same thing. And what I'm going to cover today is exactly learned by both the Form 4 and Form 5 ya. Okay, masalah dengan light chapter ni, if you are Form 5, you know that this is one of the most difficult chapter. Or usually you will fill this chapter and together with chapter 2 lah. Tapi chapter 5 ni macam tak tahu apa-apa benda. Chapter 2 pula terlalu banyak nak belajar. Okay, that's the difference between your chapter 2 and chapter 5 here. And for Form 4, among all your chapters, they made your life easier. Your chapter 2 now is easy for Form 4 KSSM. Tapi your masalah will be your last chapter, which is the light chapter, which can be quite difficult to understand because it's all very related. Okay, now apa yang cikgu akan cover hari ini adalah one of the subtopic of the whole chapter. Okay, of course this is not only about this, there's many things there, but for today's class I'm just going to cover one small topic. For the one sitting for exam SPM this year, total internal reflection is quite important and critical angle is important more on your structure, may also be important for your essay, tapi more on the structure for this year lah. Okay, now let me start to introduce about apa ini critical angle atau angle here or total internal reflection ya. So what we call here as critical angle or total internal reflection ni, critical angle ni adalah sudut genting, Malay, sudut genting, manakala total internal reflection ni adalah pantulan dalam penuh. Okay, pantulan dalam penuh. So let's start with sudut genting or what we call as a critical angle here. Now, if you're looking at any revision book, they would have given you a very long definition for critical angle, which I'm going to shorten today to give you what is the key point. Apakah key point for you to define a sudut genting ataupun critical angle here. Now, for that, always remember the first thing here, setiap objek mempunyai sudut gentingnya yang tersendiri. Okay, every object has its own critical angle and sudut genting atau critical angle ni adalah value yang constant. Maksudnya dia takkan berubah-ubah. Kalau objek A ni katakanlah speaker ni murid-murid pelajar, let's say this speaker has critical angle atau sudut genting sebanyak 40 darjah. Okay, so this critical angle is the is a value that is going to be constant, tidak akan berubah. Kalau 40 darjah, maksudnya mana-mana I bawa speaker ni, critical angle dia akan tetap 40 degree Celsius. Sorry, not degree Celsius, just 40 degree. And if I'm looking at maybe this cup here, okay, katakan sudut genting cup ni adalah 55 darjah. Maksudnya sudut genting gelas ni tidak akan berubah di mana-mana pun cikgu bawa gelas ni, tetap sudut genting dia tetap constant 55 darjah. So first of all remember, sudut genting ataupun sudut genting ni adalah constant value. Every object has its own critical angle, tapi value dia adalah constant. Dia takkan berubah. Okay. So example, I'm going to give you an example of this object here. Let me call this object here as a glass here. Dan katakan gelas ini mempunyai sudut genting dia ya. Katakan sudut genting kelas. Simbol untuk sudut genting pula ya. Simbol untuk sudut genting ni kita akan gunakan C. C adalah sudut genting ya. So the critical angle symbol gonna be C. Dan katakan sudut genting gelas ini adalah sebanyak 45 darjah. Okay. The critical angle value here is 45. Now remember what I said. Critical angle akan berubah ke tidak akan berubah kelas? Please do type in the chat. Tidak akan berubah. Thank you, Alisa. No, wouldn't change. Remember, it is a constant value. Okay, now. So this glass here has a critical angle of 45. Okay, before I go detail, this is for Form 4. This is Form 4, very basic one. You guys know the difference. Oh, you guys have already learned in your waves, hopefully. You must know the difference between reflection dengan refraction, ya. Pantulan dengan pembiasan. Reflection and refraction. Okay, I'm sure you guys have learned this in your chapter number 5 for Form 4. Di mana reflection maksudnya pantulan. Kalau kita ada sesuatu objek, the moment it hits or incident on a plane, apa yang akan terjadi? Cahaya ni akan dipantulkan ya, akan dipantulkan dan sudut tuju dan sudut biasan, sudut pantulan adalah sama. The incident angle and the reflected angle will remain the same. That is reflection. Whereas another one we have a refraction ya. Example here, if a light is passing through two different medium, let me use a blue color because I want to represent this as a water. Katakan cahaya menuju daripada udara ke arah air. Okay, so what do you think will happen to the light here, class? The moment dia incident pada surface air ni, ini air ya, water ya, apa yang akan terjadi kepada cahaya tersebut? Akan bend, betul. Tapi dia akan bend terhadap ke arah normal ke menjauhi normal? Towards normal. Why? The light is travelling daripada kurang. Ken Pulin, just ask them to join. Just pass them the link. Ask them to use the real name and join here. Later, I'll contact them. Okay. Okay. Now, going back to here. No, some of you are sending me private message, so that's why you feel suddenly what I'm talking about here. So that's why I'm replying the private message as I'm teaching here. If Ken, please put the message for everyone so they don't feel I'm talking to myself. Okay, but Naman, let's come back to here ya. Jadi dalam case ni, cahaya ni bergerak daripada udara ke arah air. That means it's moving from a kurang tumpat kepada lebih tumpat. Exactly, from low density to high density. So what going to happen? The light ray ataupun sumber cahaya ni akan dibiaskan mendekati normal. Okay, it will be bended towards the normal. Okay, this is just a very basic. I hope you know all this, but today's class is not about that. Okay, today's class is about critical angle and total interreflection. So let's come back to our lesson today ya. Now, katakan sekarang ni gelas ini mempunyai sudut genting 45 darjah dan I'm gonna exactly have a light ray, okay, satu sumber cahaya, okay, incident on this glass here. Dan katakan sudut yang dibuat ni, sudut tuju dia, the incident angle, let's say is equals to 44 degree. Sudut tuju adalah 44 darjah, sudut genting adalah 45 darjah. Sekarang ni kelas, apa kaitan di antara sudut tuju dan sudut genting ni? Sudut tuju dan sudut genting. Apa kaitan di antara sudut tuju or the incident angle and sudut genting, the critical angle? Apa kaitan dia di antara kedua-dua sudut ini? Are they equal? Is the incident angle more than the critical angle? Or the incident angle smaller than the critical angle? Which one is correct? From the drawing. Please do reply. You can either choose I is equals to C, I more than C, I less than C. Katakan ini. Okey, jadi daripada drawing ni pun sangat clear ya. Sudut tuju dia, the incident angle is only 44. The critical angle was 45. So, of course, the correct answer is incident angle is smaller than critical angle. So, in this case here, let me use the key points here. I don't want to write it down very long. Maka I can say here from here, sudut tuju adalah lebih kecil berbanding sudut genting. Now, this is what you must remember. Whenever in case when incident angle is smaller than the critical angle, what will happen? The light ray will be refracted. Akan dibiaskan. Jadi, cahaya ni akan dibiaskan apabila sudut tuju adalah lebih kecil daripada sudut genting dia. So what going to happen to this light ray here? The light ray will be refracted. Clear up to here? Ken? Any question? Any questions you all have up to here? Because slowly I'm going to go a bit more detail. Okay, tak ada soalan ya. Okay, let's continue now. Okay, for Form 4, I'm not so sure you guys have dah belajar sampai sini ke, tapi yang ini somewhere in the middle of chapter 6 ya. Initially you will start about cermin, okay, about lights and so on, then you will come back to this, okay? So I'm skipping some parts and covering this for today, okay, because it's also important for Form 5. Now, the next thing here, katakan example yang kedua ni pula, let's use a different color. Let's say sudut tuju ni kali ni, sudut tuju dia adalah sama dengan 45 darjah. Sudut tuju adalah 45 dan sudut genting pun adalah 45. Class, what is the relationship between the incident angle and the critical angle here? Okay, they are equal. The incident angle adalah 45, critical angle pun 45, maka kedua-dua adalah sama. Jadi I sama dengan C. Always remember, apabila sudut tuju dan sudut genting adalah sama, when they are equal to each other, what will happen to the light ray here? The light ray will be refracted, pun akan dibiaskan, tetapi akan dibiaskan 90 darjah ya, 90 darjah daripada garis normal. Okay, let me repeat. Apabila sudut tuju dan sudut genting adalah sama, okay, maka pembiasan akan berlaku, tetapi pembiasannya adalah 90 darjah daripada garis normal. When the incident and the critical angle are equal to each other, the refraction will form refracted 90 degrees from the normal. From normal. Any problem up to here? Okay, now, so from here, I am going to the definition of critical angle. Kalau you lihatkan dalam definisi yang diberikan dalam any of your books, they would have seen something like this. Sudut genting adalah sudut tuju, okay. Dalam medium yang lebih tumpat, sudut biasan adalah 90 darjah, okay. So apa itu sudut genting or critical angle? Let's look on the definition. Critical angle is, definition says, okay, definition says, critical angle is the value of incident angle. Let me use a different color, sorry. Value of incident angle okay, when the light ray is refracted 90 degrees and passing through from something that I missed out. Yeah, another one more point. Yeah, another one more point. Refracted 90 degrees, passing through from denser to less denser medium. Less denser to less denser medium. Okay, untuk case ni. Let's look at the definition here. Apa yang definition dia kata? Mengikut definisi critical angle ni, okay, sudut genting adalah sudut tuju. Sudut genting adalah sudut tuju. Sudut tuju apabila pembiasan berlaku pada 90 darjah dan cahaya bergerak daripada tumpat ke kurang tumpat. Okay, look at here, class. Just now, what is your value of critical angle? 45. So isn't it the value of critical angle is equals to the value of the incident angle, which is also 45? So that's why the first one says, what is critical angle? What is critical angle? Is the value of the incident angle. Sebab kenapa? Critical angle dan incident angle dia, jumlah dia adalah sama. Dan apabila sudut tuju dan sudut genting sama, apa yang akan terjadi? Cahaya dibiaskan 90 darjah, refracted 90 degrees. Dan how does the movement of the light? Does the light moving from denser to less denser ataupun less denser kepada denser? Look at that. Light is moving from glass to air, maksudnya daripada tumpat ke kurang tumpat. Therefore, it is moving from denser to less denser. So these are the three key points that you need to look into when explaining about critical angle. Are you all clear on the definition of critical angle? Critical angle is the value of the incident angle. Okay, critical angle is the value of the incident angle when the light ray is refracted 90 degrees from the, and light ray is traveling from denser to less denser medium. Okay, any questions? Any questions? No, yeah? Okay, let's continue. Let's continue, but I see my diagram is too packed here. So I'm going to redraw back this diagram here. Kalau tak confusing, katakan kali ni kita lukis balik ni. Kita lukis balik ni. So let's say we have something similar like just now. And we're going to have a normal line. Dan tadi objek dia mempunyai critical angle berapa kelas? Sudut genting dia 45 darjah. Tapi kali ini, okay, nama video. Okay, but let's say now your incident angle is equals to 47 degree. Sudut tuju kali ini adalah 47 darjah. So sudut tuju dia adalah sama dengan 47 darjah. Class. Now can you compare your I and C? What is the relationship between I and C now? I adalah lebih besar daripada C. Now, apabila cases where I adalah lebih besar daripada C, maka apa yang akan berlaku adalah apa yang kita panggil sebagai pantulan dalam penuh ataupun total internal reflection will occur. Okay, when the incident angle is larger than the critical angle, when the I is more than C, what going to happen? The light ray will undergoes a total internal reflection. Maksudnya cahaya ini akan dipantulkan, dan kalau pantul kita dah tahu dah sudut tuju dan sudut pantulan adalah sama, so that for the two here going to be equals to 47 and 47. So let's relate back. What happens? First point, when I is less than C, apabila sudut tuju lebih kecil daripada sudut genting, apa yang terjadi kelas? Cahaya ni akan dibiaskan macam biasa. Okey, akan dibiaskan sebab kenapa? Cahaya melalui dua jenis medium yang berketumpatan berlainan. So it's going to be refracted. Now, when the I is equals to C, what will happen? The light ray still refracted, but refracted 90 degrees from the normal line. 90 darjah daripada garis normal. Okay. Okay. Now, dan yang terakhir ni, apabila sudut tuju ni lebih besar daripada sudut genting, maka pantulan dalam penuh akan berlaku. Okay, so you must know the difference We'll look into more questions in a while, but do understand the difference between normal refraction, critical angle, and then total internal reflection. Any questions you all have? Okay. Jadi apakah syarat-syarat untuk pantulan dalam penuh ni berlaku? Okey, apakah syarat-syarat untuk pantulan dalam penuh ni berlaku? Yang pertama, syarat pertama, sudut tuju mestilah lebih besar daripada sudut genting. The incident angle must be larger than the critical angle. Yang kedua, okay, syarat yang kedua, the second rule says the light ray must travel from denser to less denser medium. Denser to less denser. Okay. Remember ya, kalaulah cahaya ni dia bergerak daripada katakan dia bergerak daripada udara ke gelas. Okay, udara ke gelas, maka pantulan dalam penuh tak akan berlaku ya. Pantulan dalam penuh cuma akan berlaku when the light ray is travelling from denser to less denser. Dia mesti daripada tumpat ke kurang tumpat. Dia kalau lain dia cerita dia kurang tumpat ke tumpat, dia takkan terjadi. Are you all clear on this? Okay, great. Now, I'm exactly combining critical angle and total internal reflection and so on because we are covering something that people learn for at least 2 to 3 hours in 1.5 hours to 2 hours class. So here and there I will combine, but again, whatever I'm covering, we already covered everything for this two topic, critical angle dengan total internal reflection. Now, balik kepada sudut genting. Sudut genting ni adalah formula dia. Formula dia menyatakan bahawa N sama dengan 1 per sin C. Okay. Di mana N ni apa kelas? What does the N stands for? Anyone? Refractive index. Okay. Refractive index. Okay. Refractive index ataupun dalam bahasa Melayunya indeks biasan. Okay. I don't want to go through very detail about apa tu indeks biasan, but for Form 5, because I have 3 or 4 of you with the Form 4, it's okay if you don't know, okay, but you will learn this Form 4 people. For Form 5, ni I nak challenge Form 4, Form 5 ni. Berapa banyak equation kita ada untuk N ya? How many equation do you have for N? Nothing related to critical angle and total. Abi says 3, Faiz says 3. Yang lain? Okay. Let's take a vote now. Let's take a vote. Banyak sangat yang cakap 3 kan? Okay, fine. Let's take a vote. How many of you say 3? Please click yes. How many of you say 3? Please click yes. 4, 5, 6, 7, 8, 12, 13, 14, 15, 13. Okay, 14. Okay, good. 15 daripada 36. Very good. 16. Okay. Half of the class lah ya. Half of the class menyatakan bahawa okay, good. How many of you say dah habis dah voting tu. How many of you say ada kurang daripada 3 sahaja? Kurang daripada 3. Maksudnya 1 ataupun 2 equation je. Please click yes. Tak ada orang ya. Okay, very good. How many of you say ada 4 equation? How many of you say it's got 4 equation? Okay, 1 person says 4 equation. Who is that? 2 person says 4 equation. Okay. Siapa dia? Kak Shi and who's the another person? Senhang. Senhang? Or Kak Shi? One of you. Okay lah, maybe Senhang lah. If you can unmute yourself lah. If you can unmute. Can you tell me what are the fourth of... Okay, never mind. We'll talk about the 3 formulas. Then Senhang, I'm going to ask you what is the 4th formula that we're going to look at here. Yeah. Now, so let's go back to here. Untuk Form 4, jangan worry sangat lah. You will learn all this. Okay. Don't see apa ni banyak sangat benda. Yes, there's a lot of things here. But it is not that difficult if you learn stage by stage. But since you're Form 4, you might be a bit lost. Sebab I tak cover semua ni tadi ya. Jadi yang soalan yang pertama ni, all of you know. Form 5, equation pertama ni. Sin I over sin R. The basic lah ya. Okay, lepas tu equation seterusnya apa dia? Apa lagi equation? Okay, one more is 1 over sin C. Okay, very good. 1 over sin C. Okay. Apa yang ketiga ni kelas? Banyak yang kata 3 tadi kan. So I dah tulis, cikgu dah tulis 2 dah. Mana lagi satu ni kelas? What is another one? You can type, you can mute, anything that you like. Jaden, what is another one? Najwa? Okay, so Sashwin kata N sama dengan C over V. C over V here, there you see, there's 4 already. Therefore, that's why I said Senghan is correct and also Katchi is correct just now. C ini adalah halaju cahaya dalam vacuum, B ini halaju cahaya dalam medium dia, dan yang N seterusnya adalah real depth over apparent depth. 4 ya, real depth, okay, over apparent depth. Okay, anyway, that's just a quick revision for you guys in Form 5. For today's class, we're not going to look in all this, okay? Hopefully, we're not going to look, okay, N ni memang penting lah, N ni kita akan tengok. Apa tu N and so on, I won't explain today. But again, the only formula that we're going to look into today is not this, not this, not this. We are only looking at N equals to 1 over sin C only. Tapi remember ya, ada 4 formula ya. Class, one more question. Katakan ini 1, ini formula kedua, ini formula ketiga, ini formula keempat. Form 5 again ya. Kalau soalan tanya, apakah maksud indeks biasan? Or what is the meaning of refractive index? Which formula do you use to explain the meaning? 1, 2, 3 or 4? My question again. Katakan soalan tanya, apakah maksud indeks biasan or what is the meaning of refractive index? Which is the definition that you're going to use here to explain? 1, 2, 3 or 4? Please participate, all of you. So Priya says 2, Siti says 1, Alisa says 1, Avi says 2, Tex says 1, Najwa says 2. Okay, let's stop there. Tak ada orang pula yang dapat jawapan betul kali ni. The actual formula we're going to use is C over V. Definition wise, definition of refractive index, okay, is ratio of speed of light in vacuum. Sebab C ni kelajuan cahaya dalam vacuum to speed of light in medium. Okay, are you guys clear on this? So that's the formula. But anyway, this is just for your information. I'm not going to cover anything here. So let's go back to here back again. That's just deflecting from our topic today. Yeah? So this is not in our topic today, but this is what the basics of your refractive index. Okay, so I'm going to put this as a star. And Form 4, don't worry, you will learn this later. Okay, now let's go back to here. So tadi ni kita cakap pasal total internal reflection. So total internal reflection ni dia ada 2 syarat ya. Yang pertama, sudut tuju mestilah lebih besar daripada sudut genting. Yang kedua, cahaya ni bergerak daripada yang tumpat ke kurang tumpat, dan formulanya kita dah belajar 1 je sekarang ni, di mana formula dia adalah N sama dengan 1 per sin C. Now, total internal reflection, there's 2 things here that I also missed out here. Another part here, phenomena. Fenomena ni apa-apa yang boleh dikaitkan dengan total internal reflection around you. Can you guys give me some example, especially Form 5? Can you give me some example of phenomena? Bukan aplikasi ya, fenomena yang berkaitan. Road marriage, okay? Road marriage. Ataupun dalam bahasa Melayu dia logamaya ya, logamaya. Okay, now let's stop there. Rainbow. Okay, let's go to rainbow in a while. How many of you doesn't know what is road marriage is? Can you click yes under the chat? Under the participant. Tak tahu apa tu logamaya? Tak pernah dengar? Pertama kali dengar? Atau road marriage? Okay, 3. Okay, Mian ada reason. Najwa, Wenjuan, Priya. Okay, 4 ya. Okay, the rest is okay. Jaden, okay, good. Okay, never mind. Today we'll do a question based on that. I'm just asking this so that I know how many of you doesn't know, so that I know whether I want to do questions on that or not. Okay, thank you so much. So road marriage is one of the example. What is that? Don't worry. And another one is rainbow ya. Bagaimana pelangi ini terbentuk, itu adalah disebabkan oleh total internal reflection. But due to a limited of time today, I will only explain about road marach in a while. Logam maya ni I will explain to you by today. Now, aplikasi ni pula. Apa kegunaan total internal reflection? Dia ada banyak kegunaan. Okay. One of it is a prism. One of it is prism. Okay, we'll learn about prism today. Another one is fiber optical fiber. Okay, another use of it. Another use going to be also is binocular. Okay, yes, binocular is another one. Okay, binocular is another example of aplikasi ya. Binocular ni menggunakan konsep yang sama,